Hello beautiful people and welcome. In this video we are talking about geometric series. Now we already talked about infinite geometric series. In this video we will only be referring to finite geometric series. If you haven't watched the infinite geometric series video, go ahead and do so now before watching this one. Ultimately it doesn't really matter because the formulas are going to be different. All right, let's talk about series. So series are the expressions formed by adding the terms of a sequence. So let's say you have a geometric sequence and we want to add all of the terms together. And in this case, we're doing finite, meaning there is an ending to that list of numbers. So we know that there's a first number that we're adding, there's a last number that we're adding, and adding all of them together is the series. Now, the finite geometric part just means that those numbers in that sequence have a pattern and each number gets multiplied by a common ratio. All right, let's go ahead and do a quick example of the difference between a finite and an infinite. Now, again, this is going to be super duper basic, but I just want to show you. So if we have a geometric sequence, so let's say 2 times 2 is 4, 4 times 2 is 8. A finite will tell you, it can look like it can definitely have 3 dots. However, they have to tell you when it ends. For example, n is equal to 10. That means that the last term is in the 10th position. There are no other terms after the 10th position. The pattern stops. Now, an infinite series will be something like 2, 4, 8, ... but there's nothing that comes after this ... What that means is the pattern is infinite. There is no stopping that pattern. We're going to continue multiplying by 2 forever and ever and amen, right? There is no ending. When we're doing sigma notation for a finite, you're going to have an upper limit. For an infinite, you're not going to have an upper limit. So in this case, you have an infinity as your upper limit because it never ends. Infinity is just a concept. And then for this one, you're going to have your whatever number you have as your upper limit. I'm going to say n as your upper limit. So keep that in mind, that if you have infinite and finite, those are two different things. Also, for infinite, you have to check if it converges or if the absolute value of r, diverges. If it diverges, it does not exist. If it converges, we find the sum. However, that's infinite. We're focusing on finite. Finite's a little bit easier because we know that it is going to add up to something. We know when it starts, we know when it stops, we know when to add it all together. So we don't have to check what r is in finite. Make sure you know the difference between infinite and finite. Anyways, let's move on. Formula time. For the summative formula, you still have your sigma notation. Make sure you are aware that this is your upper limit. This is your lower limit. Here's your rule. Here is your S sub n. Again, this is the n is your total quantity of terms that you're adding. Remember that formula, upper minus lower plus 1 for your total number of terms. A sub 1, you know what A sub 1 is? A sub 1 is your first term of the sequence. It doesn't mean that it's the first one here as in 1. It's the first term. So if your first term starts at position number 3, this A sub 1 will be A sub 3. It's the first term in the position. Let me actually write that down. I'm going to say first term in position of lower limit. So if your lower limit is 3, that means your first term is in the third position, not just A sub 1. We have n. N again is the term number, so how many quantity of terms that we have. Again, let me do that. So number of terms. We do your upper minus your lower plus 1. So make sure you do that every single time. Now it's going to be like a mental check, because if you have a lower limit of 1, then your upper limit is going to be your term number. I mean, if you start with something with 1 and then you end up counting to, I don't know, 10, you're going to have 10 terms. However, if your lower limit starts at 3 and you count up to 10, that's totally different quantity of numbers that you're going to be adding up. Please make sure you know that. R, you know, is your common ratio. And of course, you find that from finding your formulas. That is pretty much it. Let's go ahead and jump into some equations, problems, samples, examples, you know the drill. All right, example number 1. Again, for all of these, our task is to find the sum of the geometric series. So we know this is finite. How do we know this is finite? Because they tell us that the last term is in the 6th position. So because I know that my last term is in the 6th position, I am here. I'm not memorizing this. I am having my cheat sheet out. My formula is S sub n is equal to a sub 1 times 1 minus r to the n power, all divided by 1 minus r. Now, I don't have to do the number check, the total number of terms that I have. The reason I don't do that because this is my first position, my second, etc., and this is my 6th position. So if I start with my first position, I'm going to have 6 total numbers that I'm going to add up. So you need to do the check is if you're starting with something that's not in the first position. So S sub n is equal to, so what is in the first position? 54 times 1 minus r. I don't know what r is yet. I'm going to skip it. I am going to put in parentheses just because I want to know that that's where I'm putting my r. My n is 6. I should have put 6 here. Let's see if I can save it. Yes, I can. And all of this right here is being divided by 1 minus r. Again, I'm putting that in parentheses because I still need to figure out what r is. Remember, common ratio. Take your right divided by your left. 36 divided by 54. Take your right divided by your left. Take your right divided by your left, and make sure all of that equals the same ratio. Let's see here. 36 divided by 54, that is 2/3. 24 divided by 36, that is 2/3. And we're doing a happy dance if it works that one more time. Whoop, press the wrong button. And it does. So my common ratio is 2/3. And again, I personally like to do the denominator first. Yes, it is kind of not order of PEMDAS, but I just like to get that out of my way. So I do 1 minus 2/3. So I have 1/3 in the denominator. In my numerator, please make sure you use PEMDAS, meaning exponents come first, then parentheses, right here, parentheses, then exponents, but you can't evaluate this unless this is done. So let me even highlight that for you. So do your exponent first. So you're going to have S sub 6 is equal to 54 times 1 minus 2/3. Make sure 2/3 is in parentheses before you raise it to the 6th power. So I have 64 over 729. Yes, that's going to be looking weird. Don't worry about it. Just keep plugging, chugging numbers into your calculator. 1 minus 64 divided by 729. And again, that's 54 times 665 divided by 729, all divided by 1/3. Again, very weird. That's okay. So let's see what else we got. We're going to multiply that by 54. Whoops. Multiply that by 54. And we're going to multiply that by 3 because it's dividing by. And that gave me a very, very weird looking number. And that's okay. Let's double check. because it really did give me a weird number, so I want to double check. Here is my common difference, 2/3. Yes, 2/3. And then, yeah, because you know what, you guys, I'm going to write it down what it gave me. It gave me something weird. It gave me 1,330 over 9 as my summative value. Now, that could be it. I mean, that could be it. And I'm thinking in my head, 54 plus, if we have this, 54 plus 36 plus 24 plus 16, that's going to be 130. And it's going to keep getting smaller. So, but will it, oh, yeah, because we're going to end up multiplying. Yeah, because we're going to end up having a fraction. If I keep multiplying by my common ratio, which is 2/3, eventually I'm going to have a fraction. 2/3 times 16, that's already 32/3. And then I get to multiply that by 2/3, which is 64/9. So it does end up being a large fraction. Oh, I got a little bit worried. I'm like, what the heck is happening? Okay, let's go ahead and go to example number 2. This time, they don't give us what the term number is, the last term. They give us the actual number. So they don't give us the position of this number. So this is your a sub n. They do give us the first term, which is your a sub 1. So we're going to have to figure out what position this is in order to find out what your summative is. So in this case, we're going to have to go back to geometric sequences. So a sub n is equal to a sub 1 times r to the n minus 1 power. Because I am starting with my position number 1, I have to use the formula for position starting at 1. So a sub n, we don't know. Actually, we do know what a sub n is. A sub n is 3,072, and that's equal to a sub 1, which is 3 times r. I do know what r is. I'm multiplying by, what am I multiplying by? 2 each time. And I don't know what n is, but I do know that I'm going to be subtracting 1. And here, I don't know what this is, so I'm going to divide by 3 first. So 372 divided by 3, that is 124, is equal to 2 to the n minus 1 power. Now, here's the trick, you guys. You can separate this out, but this is going to be your one-to-one property. Is you're basically saying 2 to what power minus 1 is 1024. So you're going to do a little game, and you're going to say 2 to what power is 1024. So I'm just going to do just kind of off to the top of my head. I promise you guys this was so not planned. But I did 2 to the 10th power, and it gave me 1024. So if these two sides of this equation are equivalent, then that means 2 to the 11 minus 1 is equal to 2 to the n minus 1. So that means that our n value is 11. Right, now that we know that our n value is 11, we get to plug it into our equation. So S sub 11, because now we know what n is 11, is equal to a sub 1, which is 3, times 1 minus r, which is, what did we say, 2, and we said was 11. All of this is being divided by 1 minus r, which is 2. Use your calculator a little bit more than you want to, I know. 2 to the 11th power. So I have 3 times 1 minus 2,048. You guys, these numbers are not going to be pretty because we're adding 11 different numbers together. That's okay. So now I have 1 minus 2048 times 3 divided by -1. So when I take all of those 11 numbers together, it gives me 6,141. Now, there are no units for this. If you're, itching to put units, don't do it because these are just numbers. These are just integers. Let's do one more example. Okay, this is summative, right? Here's what we have. I have an equation, and that equation, where's my cheat sheet? There it is. Geometric explicit formula, again, starting at a sub 0. I don't have an n minus 1 here, so that means I'm starting for 0. My index is also starting at 0. That means that this number right here is a sub 0. That means that this number right here is your r. That helps because now when we have our formula, s sub n is equal to a sub 1 times 1 minus r to the n power divided by 1 minus r. This a sub 1 is not actually a sub 1. I know it's a little bit deceiving, but this right here is just your first term. Whatever that first term based off of your index. So if your lower limit is -3, that's never going to happen, but if it's -3, then you would have to find what your term in the -3rd position would be. That's what I mean by that. All right, let's plug and check and call it good for this video. So we want to find out the summation. Again, this is our upper limit. Oh, let's make sure that we have the total number of terms. I have 20 minus 0 plus 1. So that means, how many terms do I actually have? I have 20 plus 1. So that means I have a total of 21 terms. So this is the reason why. Let's do another quick thinking bubble. So let's say I have my sequence, and here it became a series because I'm adding them. In my a sub 1, in my a sub 0 position, I have 4. Then I have my a sub 1, a sub 2, and this is a sub 20. So when I'm asking you how many total terms do you have, what I'm asking is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Because we're starting at a sub 0, that means I have an extra number to count. This is my 1, 2, 3, 4, etc. So notice for my a sub 2, that's actually the third number I'm adding. In my a sub 1, that's actually the second number I'm adding. So please be careful when you're doing that term numbers. Okay, so what do we have? S sub 1, just kidding, what do we say? 21 is equal to a sub 1, which is again the first term, which is 4, times 1 minus r, which is 1/2, raised to the n power, which is, what is that? 21, all divided by 1 minus 1/2. Again, use parentheses, so inside parentheses, I'm doing 1/2. I'm raising that to the 21st power. That gives me a massive fraction. I'll let you guys see that as well. There it is. That's my massive fraction. Then, honestly, what I'm doing to my calculator is I'm doing 1 minus all of that. I don't want to type it in, but I'm doing 1 minus that. I need to make sure that this comes up to what I want, and I do. Then I'm going to take this answer, I'm going to multiply by 4, and I still have to divide it by 1/2. Because 1 minus 1/2 is 1/2. When you're dividing, make sure that you are dividing here. And that gives me this number. Lordy, that's a massive number. Let me make sure that that is okay. I'm going to write it down. All right. Let's go ahead and I'm going to triple check this. Calculators sometimes do make mistakes. So 1/2, oops, being raised to the 21st power. I'm going to subtract 1 minus that fraction. Then I'm going to multiply by 4. Then I'm going to divide by 1/2. Ooh. And now it gave me something completely different. So now it gave me 2, which is weird. So I'm going to do that again because I like the answer 2 better. But I'm going to try it again. And I'm going to show you guys what I'm doing. Let me see if I can show you. And I do want to show you guys this, that you have to double check your answer. Calculators can misinterpret what you are doing. So 1/2 raised to the 21st power. Then I'm going to say 1 minus this fraction. Make sure it's saying what you want it to do. Yes. Taking this answer, right? I'm taking this fraction. I'm multiplying it by 4. I'm going to then divide that by 1/2. Make sure 1/2 is all in parentheses. And it's giving me my original. So why, in the beginning, did it give me 2? Gave me this one here. So we're going to stick to this one. Again, if it ends up, I'm going to double check one other time. If it ends up not being it, I'm going to jump in here and let you guys know. All right, beautiful people, that is it. I went ahead and triple checked this answer. This is the final answer. As always, thank you so much for watching my videos, and I will see you in the next one. If you have any questions and you are in my class, definitely reach out so I can help you out with this. This stuff is not easy. As always, reach out to me, ask me questions during class, after class, and I will see you in my next video. Bye!